Talking Trees with Lily and Jad. Welcome to today's episode of Talking Trees. In this episode, we'll dive into the mechanisms that trees use to survive winter. We'll explore how trees protect their cells from freezing through changes in cell membranes, production of natural antifreeze, and a transition into a glassy state. We will also emphasize the importance of winter care for trees. Let's dive in.
All right, so let's dive into something pretty cool today. I mean, something that you guys deal with every day as arborists.
Yeah.
And that's how trees, especially the Acadian forest region, survive those tough winters. And we're going beyond the basics here, folks. We're getting into the nitty-gritty, like the cellular level.
Yeah.
How do they actually survive when the temperatures, really plummet?
Yeah.
We've got two sources for this deep dive. One is a study on winter warming and how it affects germination, and then an article that kind of digs into some of the surprising ways trees avoid freezing damage.
Mm-hmm.
So what do you think? Pretty fascinating stuff.
It is, yeah. It's really easy to think that, winter's just downtime for trees, but that couldn't be further from the truth. What we see as stillness is really a super sophisticated survival strategy. And it's all happening, on a microscopic level.
Yeah. So let's unpack that strategy a little bit.
Mm-hmm.
We know dormancy is a key part of that. And it's not just cold temperatures, right? It's triggered by those shorter days in late summer, prompting trees to prep for winter well before the first frost even hits.
Right.
And I mean, you guys know this better than anyone, but those amazing fall colors, that's a big sign that pre-dormancy is starting.
Well, it is. Exactly. Yeah. And that transition into dormancy, it isn't just on or off.
Right.
It's fascinating because it actually involves 3 phases: early rest, winter rest, and then after rest. Each phase has its own, its own set of changes happening physiologically. Almost like a choreographed sequence, like a manual.
Oh, that's interesting.
A tree's winter survival manual. And understanding these phases, that's huge for you guys as arborists, right? Because it helps you make good decisions about when to prune or when to transplant.
Yeah.
Or, other practices without messing with the tree's natural rhythm.
Makes total sense. Okay, well, let's talk about one of the most obvious changes, as we see trees entering dormancy, and that is leaf loss.
Right.
The article talks about how important that is, for deciduous trees.
Yeah.
But I'd love to hear you sort of expand on that a little.
Sure, yeah. Deciduous trees, they shed their leaves, mainly to conserve water during the winter.
Okay.
If they kept them, they'd risk losing too much moisture through transpiration. The process where water evaporates from the leaves.
Right.
And, when water freezes, ice crystals can cause a lot of damage to those delicate cell structures. It's almost like leaving a hose full of water outside when it freezes. Not a good outcome.
Yeah, no kidding.
Not at all.
No. So deciduous trees are like minimizing that potential damage just by getting rid of those leaves.
Yeah, exactly.
But what about conifers? They seem to hold on to their needles, pretty much all year round, with a few exceptions, of course.
You're right. Most conifers, they've evolved needles instead of those broad leaves. And the needles, they're packed with stuff that helps them, conserve water, smaller surface area.
Oh, okay.
Waxy coating, so they can reduce that water loss and keep those needles for much longer.
Yeah, it's amazing how different trees kind of, develop different strategies to deal with the same problem.
It is.
Now, even with those strategies, freezing temps are still a threat, right?
They are.
The article mentions these kind of mind-blowing ways that trees protect their cells from that freezing damage. It mentions 3 main ways. And honestly, they sound like something out of a sci-fi movie.
They do. They're pretty remarkable. Adaptations they've developed over thousands of years.
Right.
So the first one involves increasing the flexibility of their cell membranes.
Oh, yeah.
So during cold acclimation, those membranes become more pliable. It allows water to actually move from inside the cells to the spaces between them.
Oh, wow. So
it reduces the chance of ice forming and damaging those cells.
So almost like giving those cells a little breathing room.
Exactly.
Yeah. Okay, well, what about that second method then?
So think of it as, like giving the trees their own antifreeze.
Okay.
As the days get shorter, they start converting starch into sugars.
Uh-huh.
And these sugars, they act like, a natural antifreeze,
Oh.
lowering the freezing point inside the cells.
So the cells actually have like their own built-in defense.
Yeah, they do.
That's incredible. But that third method, the glass phase that you mentioned, that one really caught my attention. What is that?
That one's really fascinating. So through those first two methods, the stuff inside the cell gets more and more concentrated.
Okay.
And then at a certain point, it changes into this glass phase. It gets so viscous that it's almost solid.
Oh, wow.
Like imagine the stuff inside turning into, kind of a cellular slushy.
Yeah, I like that.
It's this state of suspended animation.
It's amazing. So these processes are happening inside every tree we see during the winter.
Right.
And the article pointed out something, I thought this was really interesting. A tree trunk can have unfrozen living cells right next to frozen dead cells, all at the same temperature.
That's right. That's right. And that's what, it's such a complex dynamic process, how trees experience winter. It's not uniform. Different parts of the tree are changing at the same time. It's really amazing.
That is pretty amazing. This brings up something I was thinking about. We've been talking a lot about deciduous trees, but the article also mentions, the risk of damage to newly planted evergreens, even though they keep their needles, right?
Right.
So what's going on there?
Well, that's, a really good point to bring up, especially for you guys as arborists. See, evergreens, they look, green and healthy.
Yeah.
But they can still lose water, through their needles, even in the winter. It's called transpiration.
Okay.
And the thing is, those newly planted evergreens, they haven't had the chance to, really develop those big root systems.
Right.
So when the ground freezes, they might not be able to soak up enough water to make up for what they're losing.
Right.
And this can lead to, desiccation, drying out.
Right. Okay.
Which it can, damage the tree, even kill it.
So even though they're green, it doesn't necessarily mean that they're thriving.
Yeah, exactly. Their metabolism, it's much slower.
Okay.
And, their main focus is just staying alive. That's why, good care, making sure they have enough water in the fall. That's so important.
Right.
Especially for those newly planted evergreens.
Yeah, that makes perfect sense. Now, this is all fascinating.
Yeah.
But before we move on, I want to talk about something that, really controls these changes within the tree. And that's hormones. Specifically, abscisic acid, ABA. So hormones, they play a huge role in orchestrating all these changes in trees as they get ready for winter.
Right, right.
And ABA seems to be a big part of that. So tell me more about how that works. Like, is ABA sending out the winter is coming signal?
Yeah, you could say that.
All right.
As the days get shorter, those ABA levels in the leaves, they increase. And that signals the tree to, start getting ready for winter. And that includes, leaf shedding in deciduous trees.
Okay.
Increasing that membrane flexibility that we talked about.
Yeah.
Converting starch to sugars. And getting the cells ready for that glass phase we talked about.
Right. So it's like ABA is the conductor of the orchestra.
Exactly. Yeah. And it even helps regulate water transport within the tree. It does that by controlling the opening and closing of the stomata, those tiny pores on the leaves. They regulate gas exchange and water loss.
Right.
So as ABA levels rise, it makes the stomata close, reducing water loss from transpiration. And that's, especially important for evergreens to prevent that winter desiccation we talked about.
It's incredible how everything's connected.
Yeah.
And ABA is right there in the middle of it all.
Yeah.
But I'm curious, what happens when we bring another factor into this? And that's climate change.
Right.
And that brings us to the scientific study on the Acadian forest.
Right.
So can you give us the rundown on that?
Yeah. So this study, it focused on Cypress main tree species in the Acadian forest region.
Okay.
And it looked at how simulated winter warming affected their germination rates.
Interesting.
They simulated a pretty big temperature increase, actually, 6 degrees Celsius.
That's significant.
It is, yeah.
Yeah. So what did they find? Did this warming, negatively impact germination?
Well, this is where it gets really interesting. They found that even with that big temperature increase, there was no big negative effect on germination for most of the species.
Really? That is surprising.
It is, yeah.
Why would that be? I mean, the warmer temps, they didn't affect that chilling requirement that many trees need to break dormancy.
Well, the conditions they simulated, even with the warming, they still had enough chilling days for most species to to successfully break dormancy. So those crucial chilling hours, they weren't completely gone.
So they still got enough winter even though it was warmer.
Exactly. Yeah.
That's good news, I guess, for those species at least, as far as germination goes.
It is, yeah. But there's a really important caveat here.
Okay.
While most species, seemed fine, some balsam fir seedlots, they showed some sensitivity to the warming.
Ah, so there's some variability.
Yeah, exactly.
So what does that mean, for arborists who are trying to manage these forests, as the climate changes?
Well, it suggests that some trees are just, genetically better at handling warmer winters than others. And as those temperatures rise, we might see some shifts in, what kinds of trees make up the forest.
Right.
Those that are more adaptable to those warmer conditions might start to kind of outcompete the ones that are more sensitive.
It's like a slow motion ecological race.
It is.
Yeah.
And that could cause a whole domino effect throughout the ecosystem.
Wow.
It could change, the types of wildlife that the forest can support, change the rate of decomposition, even how well the soil can store carbon.
This really highlights the importance of having, a lot of genetic diversity in these forests, right?
It really does. The more diverse a forest is, the better it can adapt to these changes. And that's something that, you guys as arborists, you can directly influence that through, careful planning and management practices.
It's a lot of responsibility, but it's also a pretty amazing opportunity to be able to, to help shape the future of these forests.
It really is.
Well, this has been, I'm already looking at trees a little differently now.
It's good. That's what we want.
This has been really eye-opening so far.
Yeah.
I'm kind of blown away by all this.
Good. And we're just getting started. There's so much more to explore. I'm excited to dig deeper.
I am too.
It's, it's easy to get focused on the tiny details, how those individual cells survive freezing. But we need to zoom out a little.
Right.
Look at the bigger picture, too. Like, think about the structure of a tree.
Okay.
Especially the bark.
Yeah, the bark. That's the tree's first line of defense, right?
It is. It's like a super efficient insulator, protecting those living cells underneath. Even the texture, the thickness, the color, that can all affect a tree's cold tolerance.
So if I picture like a tree with really thick bark, deep furrows, would that give it an advantage in a colder climate?
It very well could. Those deep furrows, they trap air, creating another layer of insulation, kind of like a natural down jacket.
I like that.
For the tree. And then, darker bark colors, they can actually absorb more heat from the sun.
Oh, okay.
Which can help in those really cold areas.
It's amazing how all these little details, work together to help the tree survive the winter.
It is. It's a whole system. And it's not just the individual tree either. You got to think about the whole forest ecosystem.
Right. The bigger picture again.
Exactly. The spacing between trees, the mix of species, even the stuff growing underneath, that understory vegetation. All that can affect how those trees experience the winter.
So a dense forest canopy, would that act kind of like a shared blanket?
It could, yeah.
Offering some protection?
Yeah, for sure. Protection from wind.
Okay.
And those extreme temperatures. And a forest that has, a good mix of deciduous and coniferous trees. That creates a more resilient ecosystem.
Right.
One that can handle all those different winter conditions. And as climate change keeps throwing us, those unpredictable weather patterns, warmer winters, understanding all those interactions, it becomes even more important.
Well, this deep dive has been pretty insightful so far. We've gone from the microscopic world of those cells to the big picture of forests and climate change.
We've covered a lot.
And we even talked about, those potential ripple effects of climate change.
We've talked a lot about how trees, adapt to the cold and conserve water.
Right.
But there's another part of surviving winter we haven't really touched on.
Oh, okay. What's that?
Weathering those winter storms.
Oh, yeah. Good point. I mean, as arborists, you guys are often the first ones on the scene, right?
We are, yeah.
After a big storm.
Yeah.
Dealing with the aftermath of all that ice and snow and wind.
Exactly. And understanding how, each tree species handles those stresses. That's key for making those decisions about prevention and care.
So let's start with ice storms. I mean, I've seen how much damage they can do.
Yeah.
Especially to deciduous trees. Those heavy ice coatings can just snap branches like they're nothing.
It's really simple physics, That ice, it adds so much weight.
Right.
And when that weight is more than the branch can handle, it breaks.
Yeah.
And the shape of the tree's crown matters too.
Oh,
Those trees with those wider spreading crowns,
Okay.
they tend to be more vulnerable.
Why is that?
Well, their branches, they just have more surface area for the ice to build up on.
Oh, that makes sense.
Yeah.
So the way you prune a tree could actually affect how vulnerable it is to ice damage.
It really can.
Huh.
Doing things like removing weak branches.
Right.
Or branches that are crossing.
Yeah.
That can really reduce the risk.
Okay.
And for some species, like willows or birches,
Mm-hmm.
they're more susceptible to ice damage. So you might need to, cable them.
Oh, right.
Or brace them.
Interesting. So it's really about thinking ahead.
It's about proactive management.
Yeah.
Anticipating those problems and taking steps to prevent them.
It's not just about preventing damage either.
Right.
I mean, after a really bad ice storm, sometimes you have to make those tough calls.
You do.
About whether a tree can be saved or if it needs to be removed.
Yeah, and that's where your experience as arborists, that's so crucial. You guys have to make those judgments.
Yeah. Okay, well, let's shift gears a little bit. Move from ice to snow.
Okay.
I would imagine that heavy snow, that's got to be tough, especially for conifers.
Yeah.
With all those needles.
It is. Conifers tend to hold on to more snow
Right.
than deciduous trees do. And that can lead to, branches breaking, especially if that snow is wet and heavy.
Yeah, for sure.
But it's interesting. Some species, like white pine,
Yeah.
they've evolved to have more flexible branches.
Oh,
so
wow.
they can shed that snow easier.
So being bendy is actually an advantage in a snowy climate.
It is. It's like, nature's built-in snow removal.
I like that. And I guess sometimes a little manual help can't hurt either, right?
Right. Carefully brushing that snow off can prevent breakage. But of course, safety always comes first.
Absolutely. Yeah, no tree is worth getting hurt over.
Exactly. And then, of course, we can't forget about the wind.
Oh, right. Yeah.
Those strong winds, they can uproot trees, especially trees that are already rent, maybe from disease or root damage.
Now, I imagine trees in exposed areas, like along the coast or in open fields, they must be especially vulnerable.
They are. And in those situations, windbreaks or shelter belts, those can really help produce those wind speeds, protect those trees. And again, good pruning practices can make a big difference.
Yeah, that seems to be a theme. It always comes back to, understanding how those trees interact with their environment. And then using that knowledge to guide us.
It does. And as we see more of these extreme weather events, stronger winds, heavier rain and snow, those skills, those are going to be even more important.
Yeah, you're right.
For you guys.
Well, this has been quite a journey.
It has.
We've covered so much, from the microscopic world of cells all the way to, forests and climate change.
Yeah, we've gone from the tiny to the huge.
Exactly. To all you arborists out there, keep up the amazing work. You guys are the guardians of our forests, protecting these incredible ecosystems that we all depend on. So, until next time, happy treeing, everybody.
Thank you for tuning in to today's episode of Talking Trees. If you enjoyed this deep dive into how trees survive the winter and want to support our work, check out our exclusive content on herohero.co/talkingtrees. Your support helps us bring more insightful episodes to you. See you next time.